In this video, I will go over a Leetcode problem, add two numbers. We are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and we are asked to sum up the two numbers represented by the linked lists. Let's look at an example. Here I have our input, the two linked lists, L1 and L2. When we add two numbers together, we will stack them up, aligning them from the right. Then we would go digit by digit from the right, adding the numbers up. We could do this in code by traversing both linked lists at once, since they are in reverse order. We can traverse a linked list using a while loop, and we want to make sure that we traverse both linked lists to the very end. So the loop needs to keep running while either L1 is not null or L2 is not null. And since the two linked lists could be different lengths, inside of the while loop, it's possible that L1 or L2 could be null. So before applying our update condition, we need an if statement. So if L1 is not null, then I could update it to the next node. And same thing for L2. If L2 is not null, then I would be able to update it to the next node as well. Now that I have the code to traverse both linked lists at once, I want to find their sum. Since either L1 or L2 could be null, I need to be careful when getting their value. So I will define val1, and I will set it equal to 0 at first. And if L1 is not null, then I can set val1 equal to the value of L1. And then I will need to define val2 so that when L2 is not null, I can set val2 equal to the value of L2. And now I can finally get my sum, which will be equal to val1 plus val2. Just to show what's going on, I will console.log the numbers. So here I have val1 plus val2, and it's going to be equal to my sum. Running the code, we can see that in the first iteration, we're looking at the first nodes of the linked lists. So 3 plus 5 is 8. Then we move on to the next nodes, and we have 2 plus 4 is equal to 6. And then for the last node, we have 0 stand in as a placeholder when the second list doesn't have a value, so 1 plus 0 is 1. So this code successfully handles the edge case when the linked lists are different lengths. Now, I still need to consider two other edge cases. I'm going to change my test case. Instead of 3, I'll have a 7. Now, in the first iteration of my while loop, the values sum up to 12, which is not a valid digit. When we sum up two numbers, we carry 1 over when the sum of two digits is greater than 9. Here, 7 plus 5 is equal to 12, so we carry 1 over and record 2. And when we sum up digits one column over, we would need to add 1 to our sum. In this case, 2 plus 4 plus 1 is 7. To account for 1 that gets carried over, I will define variable carry. Initially, it will be 0. Then I could have carry contribute its value to the sum. And once we find our sum, then I can see if my sum is going to be greater than 9. And if it is, my value will be 1, otherwise it will be 0. There is another way of writing this exact statement using math.floor sum divided by 10. And then I can define the variable digit, which will be the digit that I will record in my result. Here I will take mod 10 of my sum, and here I will console.log my digit. It calculates the sum correctly. So we handled the edge case with carry over value. There's one more edge case. I will change my number to be 99, and the other value will be 1. Now, when I add these numbers up, I will get 0, 0, but actually the answer should be 100. So what happens is the while loop only runs 2 times, which corresponds to the length of the longer number, but the result is longer than either one of the numbers. There's a simple fix for this. We can say that we want our while loop to run while L1 or L2 are defined, or while the carry value is not 0. And since we're already handling the cases when L1 and L2 are null, this will just work. So now when I run it, I get the correct value. Okay, so we have handled all of the edge cases, and we can start working on turning these digits into a linked list that we can return. I will define current node, which will be set to the list node with the value digit. In a linked list, previous node needs to point to our current node. So I will need to define a variable that will keep track of the previous node. I will initially just set it to an empty node, and then I can chain our nodes together by setting the next value of the previous node to our current node. And then I need to update my previous node be equal to the current node for the next iteration. And in the end, I would want to return my linked list. But since current and previous nodes are constantly changing, I will lose the pointer to the beginning of the linked list. So I want to define a head node, and I will set it equal to previous node. So the head node will remain unchanged, and at the very end, I can return head node.next, which will give us the beginning of our linked list. Some things that I can refactor, I can change this let to const for digit and sum since they don't change, and we should be good. And when I submit this code, it gets accepted. The time complexity is linear since the number of times our while loop is going to run will be equal to the length of the longest linked list plus 1 at most. And space complexity is also linear because I need to create a new linked list to store the result. Okay, well, let me know if you have any questions or suggestions in the comments. And for my next Leetcode problem, I'm going to do a dynamic programming problem since I haven't done that before. Well, thanks for watching and good luck with your studies.